Alright, so we're looking at compound inequalities, which are the joining together of more than one inequality statements with the words and or. And in this lesson, we'll focus on the or kind. And so, for example, this is what we're talking about. Find the value of x such that 2x is greater than 10 or 3x is less than 30. Um, so, if a value satisfies either one of those requirements, then it counts. Thumbs up for that. Works for that compound inequality. So let's solve this. And I wrote out this green, this blue and this green mean the same thing. I just wrote this out in set builder notation just to as a little side thing if you're into that. If you're not, if this is confusing or you hate it or whatever, just ignore it. But what this says is what this says. So the set A is the set where x is a real number, it's not an imaginary number, such that 2x is greater than 10. The set B is the set where x is a real number, such that x 3 times x is less than 30. Determine the union of A and B. So yeah, so this is the same thing. Um, so let us solve this. So just deal with these inequalities separately first. 2x is greater than 10, or 3x is less than 30. So we want to solve for x, so it's being multiplied by 2, so let's divide by 2. So we've got x is greater than 5, or let's divide by 3 over on this one. Divide by 3 is just a little one-step inequality. X is less than 10. So this would be your answer. X is greater than 5, and x is less than 10, or x is less than 10. Okay. You might have seen where there's you can write inequalities like this type of thing, or like what am I thinking of, like where you combine the two conditions together. Don't do that with the ors. Don't do that. Yeah, you have to write them out separately because it's confusing. Writing them all together sort of implies and. Anyway, um, x is greater than 5 or x is less than 10. So let me just kind of visualize this for you on a number line. Um, um, here's 5, here's 10. Okay, so x is greater than 5, so would not include 5, but anything that's greater than 5 would count. So um, it could be in this set, um, or it could be anything that's um, less than 10, which is this set. So actually these overlap, so any real number would count for this. So if it's either in this set, anything that's less than 10 and on down to negative infinity, or anything that's greater than 5 and on up to positive infinity would count as a solution. So really, you could say x is greater than 5 or x is less than 10, or you could say all real numbers, because actually it turns out that these overlap. So um, or just capital R. Let's try another one. 5x plus 10 is less than 25, or 10x or 10 minus 3x is less than negative 11. So let's just deal with these separately first. 5x plus 10 is less than 25, or 10 minus 3x is less than negative 11. So let's deal with this. So I want to get x by itself, so let's subtract both sides by 10. Making some progress here. 5x is less than 25 minus 10 is 15. We can divide by 5. So x is less than 15 divided by 5 is 3. So x could be less than 3, or alternatively it could be. So let's isolate the variable here. So I'm going to subtract 10x from both sides. So what I'm left with is negative 3x is less than negative 11 minus 10 is negative 21. So I'm going to divide both sides by -3 to get x by itself. Now I'm dividing or multiplying both sides of the inequality by a negative number, so I need to flip the inequality sign, so that's going to flip the other way. So x is greater than -21 divided by -3 is +7. So if x is less than 3, it counts, or if x is greater than 7, it counts. So let me actually uh, draw that also on a number line so you see what that is talking about. So we've got 3 here, let's call that 7. Actually, let me just give myself some more room here. 7. So, okay, so x is less than 3. So it wouldn't include 3, but anything less than 3 would be fine. So, any of those guys that way. Or x is greater than 7, so it can't be 7, but anything greater than 7 would be fine. So I've graphed these two conditions. So the solution set is any number that's in this group or in this group. So basically, it's anything that's not in this group. If that's another way to look at it. What's the number? Or yeah. So in here, these numbers don't count, but anything that's either over here or over here would count as a solution. So the way you'd write the answer is x is less than 3 or x is greater than 7. Or you could graph it something like that.